Have you ever pondered what the world would look like without the contributions of Sir Isaac Newton? Our story begins on a winter's day, January 4th, 1643, in the small hamlet of Woolsthorpe, England. Here, amidst the rolling hills and quaint cottages, a genius was born. Young Isaac Newton, although born prematurely and small enough to fit into a quart mug, was destined to make a giant impact on the world. He was a child of curiosity, always exploring, questioning, and seeking to understand the world around him. His mother noted that even as a toddler, he showed signs of remarkable intelligence and a relentless appetite for knowledge. As Newton grew, so did his intellect. He would spend hours engrossed in books, absorbed in the world of ideas and the mysteries of the universe. This relentless curiosity and unparalleled intellect would become the bedrock of his groundbreaking discoveries. Born into a world of uncertainty, Newton would grow to redefine our understanding of the universe. An apple falls from a tree, and a theory takes root. This is a tale that has been told countless times, and it never fails to capture our imagination. As the story goes, one day, while contemplating the mysteries of the universe under an apple tree, an apple fell and hit young Isaac Newton on the head. This incident sparked a train of thought that would change the world. The falling apple made Newton question why it fell straight down and not off to the side or upwards. This curiosity led him to formulate the law of universal gravitation. He proposed that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This law explained not just the fall of an apple, but also the motion of the planets in the heavens. Before Newton, people had different theories about the motion of objects on Earth and the heavenly bodies. But with the law of universal gravitation, Newton showed that the same principles applied to both. This was a groundbreaking idea that unified the laws of nature, both on Earth and in the cosmos. Newton's theories on gravity were met with some skepticism initially, but they were soon accepted because they could predict the motion of objects with remarkable accuracy. They were used to predict the return of Halley's Comet, which helped gain widespread acceptance for Newton's theories. The impact of Newton's theories on scientific thought cannot be overstated. They provided a framework for understanding the physical world that stood unchallenged for over 200 years until Einstein's theory of relativity came along. Even today, Newton's laws are still used in many areas of physics and engineering. In that moment of curiosity, the foundations of modern physics were laid. From a falling apple, Newton was inspired to develop a theory that continues to shape our understanding of the universe. His story serves as a reminder of the power of curiosity and the potential it has to unlock the secrets of the universe. Enter the realm of Principia, where motion and gravity dance to the tune of mathematical precision. In the heart of the 17th century, amid a world of uncharted territories and unexplained phenomena, emerged a masterpiece that would forever change our understanding of the universe. Philosophiae Naturalis Principia Mathematica, or simply Principia, was Isaac Newton's tour de force, a work of genius that set the stage for modern physics. Published in 1687, Principia was no ordinary book. It was a compendium of theories and observations, a testament to Newton's brilliance and his relentless pursuit of knowledge. Within its pages, he introduced the world to the laws of motion and universal gravitation. These weren't just theories, they were revolutionary concepts that explained the mysteries of motion and the invisible forces that bind the cosmos together. In Newton's universe, every object in motion continues in its state of rest or uniform motion in a straight line unless compelled to change that state by external forces. This law of inertia was just the beginning. Newton's second law explained how the velocity of an object changes when it's subjected to an external force, and his third law, for every action, there's an equal and opposite reaction, became a fundamental principle in the study of physics. But perhaps the most groundbreaking revelation in Principia was Newton's law of universal gravitation. He proposed that every particle of matter in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law explained everything from the fall of an apple to the orbit of the moon, providing a unified theory that described the motion of celestial and terrestrial objects. In these pages, Newton reshaped our view of the physical universe. His work in Principia was a masterpiece in motion, a dance of numbers and equations that painted a vivid picture of the universe's workings. It was the dawn of a new era in scientific thought, one that we continue to explore and marvel at even today. From the hues of a rainbow, Newton weaved a tapestry of understanding. As Newton delved into the properties of light, he conducted a series of experiments that would illuminate a path for future scientists. Using a simple prism, Newton embarked on a journey of discovery that would reveal the true nature of light. His experiments proved that white light was not a single entity, but a combination of many colors. He showed that when white light passed through a prism, it dispersed into a spectrum of colors, from red to violet. This spectrum, he discovered, could not be further separated by passing it through a second prism. His work debunked the prevailing belief of his time that color was a mixture of light and darkness. Newton demonstrated that color was an inherent property of light itself. With a prism and a beam of light, Newton forever changed our understanding of color. From the halls of academia to the helm of the Royal Mint, Newton's influence was far-reaching. At Cambridge University, he held the Lucasian Chair of Mathematics, a position of great prestige and respect. Here, he delved deeper into the world of mathematics, making significant strides in the field of calculus. Yet, Newton's advancements in calculus did not come without controversy. A shadow was cast over his work by a bitter priority dispute with Gottfried Wilhelm Leibniz, a prominent German mathematician and philosopher. Both men claim to have developed calculus independently. This dispute, known as the calculus controversy, became one of the most infamous intellectual battles in history. Each party had their supporters, and the debate raged on long after both men had passed away. Despite the controversy, there's no denying that Newton's work in calculus has had a profound impact on mathematics and science. His methods provided a new way to measure and describe the world, enabling future scientists and mathematicians to make their own groundbreaking discoveries. But Newton's influence extended beyond the world of academia. Later in his life, he served as the warden and master of the Royal Mint. In this role, he took on the massive task of reforming England's currency. With the same analytical mind that revolutionized science and mathematics, Newton tackled the complexities of economics. He introduced new standards, fought against counterfeiting, and helped to stabilize the English economy. Newton's tenure at the Royal Mint is a testament to his versatility and the breadth of his intellect. Whether he was formulating the laws of motion, developing calculus, or reforming the currency, Newton approached every task with the same analytical rigor. In every role, Newton applied his analytical mind, leaving a lasting mark. His contributions to science, mathematics, and economics have echoed through the centuries, shaping the world as we know it. His story serves as a reminder that the pursuit of knowledge and understanding can lead to discoveries that transcend the boundaries of a single discipline, a life's work that echoes through the ages. Such is the legacy of Sir Isaac Newton. His contributions to science and mathematics were not just revolutionary in his time, they continue to shape the course of scientific inquiry to this day. Newton's principles laid the groundwork for classical mechanics, a field that has shaped our understanding of the physical universe. His laws of motion and universal gravitation are still taught in classrooms worldwide, the cornerstone of any physics curriculum. His work in optics, too, has left an indelible mark. Newton's discovery that white light is composed of a spectrum of colors has shaped our understanding of light and color. It is a concept that underpins modern technologies, from the cameras in our smartphones to the telescopes that allow us to gaze upon distant galaxies. But Newton's influence extends beyond his own field. His mathematical contributions, particularly his work on calculus, have been instrumental in the evolution of a wide range of disciplines. From engineering to economics, the principles he helped establish are applied daily in myriad ways. And it's not just the fields of science and mathematics that owe a debt to Newton. His influence can be seen in the work of subsequent generations of thinkers and innovators. Figures like Albert Einstein, whose theory of relativity would further revolutionize our understanding of the universe, stood on the shoulders of this giant. The legacy of Newton is a testament to the power of curiosity and intellectual pursuit. It reminds us of the potential for one person's ideas to change the world, to open doors and light the path for future exploration and discovery. As we look to the stars or marvel at modern technology, we are reminded of the profound impact of Sir Isaac Newton. His theories continue to illuminate our understanding of the universe, a beacon of knowledge that guides us in our quest to unravel the mysteries of existence. His is a legacy that will endure as long as humanity continues to look up and question the world around us.